In this lesson we're going to be learning about something called composite functions, or composites of functions. So when you look at these problems, you're still given actually in this case, three different functions, f of x, g of x, and h of x. And we're going to be substituting one function into the other. So you might notice that it says find, and it looks like it says fog because of that zero, or that open circle there. This is what I was talking about with the multiplying. This is an example of how we're being told it's a composite. There's a couple ways to write this. Take a look at problem number 2, or I should say 3b on your notes. It says find g of f of x. There's one way to write it, and then the way we have right here is another way to write it. So we're going to show you both ways so you could recognize them if you needed to. How we do this is we're saying, if they say find, this is how I would read this, is find f of g of x. So this O here is kind of, you'd say the word of if you're reading it. What this is saying is we work inside out. They're telling me that I should take the g of x equation and plug it into the f of x equation. So what I'm going to do is I'm going to actually circle this in my notes up here. So I'm going to take the g of x equation, and in my f of x equation I would replace each x with what I circled. So everything else stays the same except where you see the x's, you'll replace that with 2x minus 1. So I would write f of g of x equals, and then I go 3 parenthesis 2x minus 1 squared minus, and I'm going to put this in parentheses, 2x minus 1, and then plus 4. So take a look for a second and make sure you can see everything I did there and why I did it. So nothing changed in my red equation except where the x's are. I replace that with a 2x minus 1. From here then, I'm going to simplify using my order of operations. So I know I would do an exponent first. So I would have to multiply 2x minus 1 times itself. I'm going to go ahead and distribute this negative right now. So I have negative 2x plus 1 plus 4. And then I continue to simplify. I would maybe go ahead and FOIL and just write this underneath here. So it's 4x squared minus 2x minus 2x plus 1. So that's me distributing. So that was going to replace this right here. So all of this is still times the 3, right? So in my next step, I'm going to go ahead and distribute that 3. So 3 times 4x squared would be 12x squared, 3 times a negative 2, 3 times a negative 2, and 3 times 1. And then I'm going to bring down my green, minus 2x plus, I think I could add those, plus 5. So now I've simplified everything according to my order of operations. Now I'm going to write my answer. F of g of x equals, and I'm going to combine like terms here. So I'd get 12x squared, negative 6x, negative 6x, negative 2 would be negative 14x, and then 3 plus 5 would give me 8. So my answers aren't going to have numbers in them because I was substituting one equation with variables into another, but this is what f of g of x is. My next one then is using the other notation, but I still do it the same way. I'm going to be taking my f of x, so that I work inside out again. I take f of x and put it in for g of x. If I read this problem, I would read find g of f of x. So those parentheses read as an of also. So this time I'm going to circle my f of x equation, and I'm going to put that into my g of x equation wherever there's an x. So I copy that equation the exact same, finding g of f of x, and I would write 2, and then where that x is, I'm going to replace that with my red f of x, so 3x squared minus x plus 4, and then from there I finish my g of x equation, I write the minus 1. So nothing changed except where the x is. I wrote 3x squared minus x plus 4. This one's a little bit easier to solve from here, so I'm going to go ahead and distribute the 2, get 6x squared minus 2x plus 8, bring down that minus 1. So my final answer, f of g of x equals, when I combine like terms, 6x squared minus 2x plus 7. And that's my final answer. Remember, you're always working inside out when you're doing these. So now if you flip to the back of your notes, you'll notice we have three different functions again, same ones, and it says find f of g of x for x equals negative 2. So now what they want us to do is they actually want us to substitute negative 2 in for x. So how this works is we still work inside out. So for this part, the first thing I see is the g of x. So I again work inside out. I'm going to first put this negative 2 into g of x. So I'm finding g of negative 2, and I replace that x with a negative 2. So g of negative 2 equals, when I subtract or multiply, I'd have negative 4 minus 1. So I find g of negative 2 to equal negative 5. Then, because the second part, we're supposed to put g of x into f, I'm going to take this answer for g of negative 2, and I'm going to put that into f of x for my answers, or for my x's. So you're substituting that negative 2 in for g of x, getting an answer, and taking that answer and putting it in for f of x. So now I have f of g of negative 2, because I replaced the x with negative 2, is, and then I'd substitute wherever those x's are, I'm going to put a negative 5. And then I keep going, and I use my order of operations, so I have 3 times negative 5 squared is 25. Negative negative 5 would be a positive 5. 3 times 25 is 75, plus 9. So I'm going to find that f of g of negative 2, because that's what I substituted in for x, equals 84. And that is my final answer. So when they give you a value for x, you're always going to get numbers for your answers. So let's look at b. Why don't you guys go ahead and pause the video and try b. This time it's written a little bit differently, so you'll see that you're going to put this negative 2 right here into f, and then get that answer, and that answer will go into g. So go ahead and hit pause, and then try that on your own and check your answer with mine. So for this one, since I'm finding f of negative 2, in the f of x equation, I'm going to replace my x's with negative 2. And then go ahead and reduce these using my order of operations. So I get 12 plus 6. So I find f of negative 2 to equal 18. So now this is what I'm actually going to substitute into g of x, because they said g here. So I take g of f of negative 2 equals, and then in my g of x equation, where that x is, I'm going to put an 18. 2 times 18 is 36. So g of f of negative 2 equals 35. And that's my final answer. In this last one, we are finally going to get to use the h one. So this one we have to substitute 3 different times. First, we're going to take the 3 and put it into the g. Then we're going to take that g answer and put it into h. Then I'm going to take that h answer and put it into f. So you're going to go slowly, one at a time, work your way through. So first we're finding g of 3. So I take my g equation, and where the x is, I'm going to put a 3. So I find g of 3 to be 5. Then I'm going to take my h equation. So now I'm finding h of g of 3. And wherever in my h equation there's an x, I'm going to put a 5. So it's 4 times 5. So h of g of 3 equals 20. Lastly, I'm going to take this answer and put it into the f of x equation. So f of h of g of 3 equals, and I have 3 times 20 squared minus 20 plus 4. So I'm plugging all of that into my f of x equation. So I take and I reduce using my order of operations. 3 times 400, that's what 20 squared is, would be minus 16 if I add those. 3 times 400 is actually 1200. And so f of h of g of 3 equals 1200 minus 16, so 1,184. Do you need to have this notation in your answer? Yes, that needs to be there, so you tell us what you were finding when you got that answer.